Show that the equation 2 cot squared x minus 9 cosec x minus 3 equals 0 can be expressed in terms of just sine. Okay, let's think about this. We want to get everything in terms of sine. Well, the first thing I'm going to do is write cot squared as cos squared over sine squared. So 2 cos squared x over sine squared x minus 9. Okay, well, cosec then is 1 over sine. So it'll be 9 over sine x minus 3 equals 0. So what we can then do is times through by sine squared. So 2 cos squared x minus 9 sine x, because when I times this one by sine squared, it partially cancels, minus 3 sine squared x equals 0. We're getting there now. We've got sine x and sine squared x. We've just got this cos squared x as well, which I need to deal with. But remember, sine squared plus cos squared is 1. So cos squared is 1 minus sine squared. And that will become, when I expand the bracket, I will get 2 minus 2 sine squared x minus 9 sine x minus 3 sine squared x equals 0. Just need to rearrange it now. So I can write, I think I can go straight there. It's just going to be 5 sine squared x, because I'm going to get minus 5 sine squared x, but add it to both sides, get it onto the right. Then plus 9 sine x minus 2 equals 0. It is a show that, but I feel like this step is, it's not like I need to show more steps there. Now we're asked to show detailed reasoning and solve in radians between 0 and pi theta this equation here. It's very similar to what we've had before. So I'm just going to let x equal 2 theta, and this means the equation will become 2 cot squared x minus 9 cosec x minus 3 equals 0. And then using a, it becomes what we had before, 5 sine squared x plus 9 sine x minus 2 equals 0. That's the one that we're going to solve. You could, in fact, solve this one directly using some trig identities, but they have said hence, so I would just definitely use the one that we've got. Okay, let's see if it factorizes. I also should just note that the range is going to change. So now I'm actually going to be looking for 2 theta. So 0 less than 2 theta less than 2 pi. So it's actually, I'm finding solutions for x between 0 and 2 pi. So just be careful about that. Right, let's factorize it. And you definitely need to do the factorization because we're showing detailed reasoning. So 5 sine x, and sine x has got to be, to get that 5 sine squared x, and then we just got to use 2 and 1 somehow. Well, if I put a 2 here, that'll give me 10x. I'm only 1 away from 9, so then put the 1 there. So make 1 a negative. This one's going to be positive. That will give me 10 sine x. If I make this one minus 1, I'll get my minus sine x. I'll get my 9 sine x as well as the other 2. So that means sine x is going to equal a fifth or minus 2. I can immediately reject this one because sine has to be between minus 1 and 1. If you don't spot that and you put it in your calculator, you'll get a math error. So then just make sure you do reject it. So that means x is going to be inverse sine of a fifth. Okay, just make sure your calculator's in radians mode. And we get 0.2013. If you're using the graphs, you see that actually that's not the only solution. There's this one here, pi minus So, or pi minus that answer. Gives us 2.9402. If you're using cast diagrams instead, all sausages turn cold, then we've got, it's a positive one, so it's here and here. So you get this solution, and then you can see to get this one, we're going to be doing pi minus this, because remember this is pi. So I'm just trying to explain it in different ways, but those are the two that you get. And then we're nearly there. We just have to, that is our 2 theta, remember. So theta is going to be 0.2013 divided by 2, which to 3 significant figures is 0.101, and 2.9402 divided by 2, which gives us 1.470. I think we're asked in the question to leave it to 3 decimal places here. Nice one. All right, and the last part of this question was told that the small angle approximation for sine 2 theta is used to find an approximation for the smallest positive solution of this equation. We have to show that it's accurate to 2 decimal places. All right, interesting. So again, we will obtain 5 sine squared x plus 9 sine x minus 2 equals 0. Actually, I need to get it back in terms of theta this time. We did a substitution, but it's actually going to be this. Probably should have gone straight to that, but I was trying to build on what we did before. Okay, so using part A, we can get to here anyway. That's the main thing. Right, now use small angle approximation. And that is that sine theta is approximately theta. So therefore, sine 2 theta will be approximately 2 theta. And sine squared 2 theta will be approximately 2 theta all squared. So therefore 5 times 2 theta all squared plus 9 times 2 theta minus 2 equals 0. And this time we've got ourselves a quadratic to solve. We'll get 20 theta squared plus 18 theta minus 2 equals 0. I can divide through by 2. Part of me wants to put this in my calculator, but we're still being asked. Okay, actually, it's only in part 1 by the looks of it we have to show detailed reasoning. Let's see if it does factorize. I'm going to go with 10 because I've got a 9 here, so it feels like it's going to have to be quite big. So if I go with plus 1 and minus 1, it works out again. If you want to use your calculator here, it's fine. Then we'll get theta is 0.1 or minus 1. I'm going to reject this one because it's not small. So actually, this is my answer. Theta is 0.1. And show that this approximate solution is accurate to 2 decimal places. So actual theta is, remember, 0.101. Our approximate theta equals 0.1. I suppose we could put some zeros on there. So you can see, not accurate to 3 decimal places, but it is accurate to 2. Just make that clear. Well done.